Okay, so now we're going to be looking at some data manipulation using dplyr. Those of you who may have used dplyr before will see that this is mostly revision, but I'm sure there'll be some of you that haven't used dplyr or perhaps haven't used dplyr extensively before, and so some of this will be good revision or perhaps entirely new to you. And we're going to be looking at a data set on the New Zealand secondary school and primary school roles, so the number of New Zealand students at schools across the country, and in fact some international students as well. And we're going to be manipulating this reasonably large data set with the tools that dplyr provides. And dplyr is essentially a language for or a grammar, I guess, for describing manipulation steps on a data set. So taking a data set in one form and transforming it or summarizing it into another form. And there really is just these 6 main verbs that you need to know and remember, but there are many, many more. It's probably up to about 100 or so, sort of more specialized ones that do something, sort of do a common data manipulation step for you, which is often the combination of 2 or more of these steps. So I think we'll just show by doing. So we're going to start off by reading this data set in off the web. And you can see that it's reasonably large. We've got 103,666 rows, just 5 columns. So we've got the school, which is a character vector, which is the name of the school. We've got the gender, or I guess this is probably the sex of the child in this case. Not actually sure what they record there, but it only contains the entries male and female. We've got ethnic group, which contains a number of ethnic groups, and as well as there's a separate category for international students, I think in the ethnic group entry. We've got the level, which is the year level of the student, of the students that we're describing, and then we've got the number of students. So each row is not representing a student, it's not representing a school, instead it's representing the number of students of at a particular school that are a particular gender, ethnic group and level combination. And so we're going to start by looking at this data set and just learning how to filter out or how to choose particular rows to return. So we're going to start with the filter command. And so this next code block here is identifying all the rows where the ethnic group is Māori. So if we run that line there, you can see that all of the rows that are returned, we now have 29,000 rather than 103,666. We now have just the rows where the ethnic group is Māori, and we can see that sure enough all of the rows there have the ethnic group Māori. So the filter command takes as its first argument the data frame that we're interested in filtering, and then the second or subsequent arguments are how we want to do the filtering. And you'll see that this is consistent across the tidyverse in general and dplyr in particular, in that all of the functions are set up the same way. So you've got some verb which describes what the function does, which is the name of the function. The first parameter is the data frame that you want to apply it to, or the tibble that you want to apply it to, and then subsequent parameters are how we want to do that particular verb, so what extra information that verb needs to do its work. And then the output is also a data frame. So there's some nice consistency there. The first argument is always a data frame, the output is always a data frame. So you don't have to, you'll never be surprised by what it gives in that regard. So in this case, we've got a single criteria for picking the rows, but you can supply multiple criteria. So if I supply 2 separated by commas, then you'll see that this returns fewer rows. So instead of having 29,000, we've only got 14,000. And that's because I required the ethnic group to be Māori and the gender to be female. So we're only getting Māori female rows returned from this. So this the comma is the same as an AND operator. So we require both ethnic group to be Māori and gender to be female for a row to be returned. If you want either or, so you are allowing rows to be returned where the ethnic group is Māori or the gender is female. So we don't mind if we get ethnic group Māori and gender male, and similarly we don't mind if we get gender female and ethnic group something else. Then we can use the OR operator, which is done with the vertical bar, which you'll find above your enter key on the keyboard. So you can see here we return many more rows because we've got all of the ones that had the ethnic group equal to Māori. We've also got all of the ones where the gender was female. Right, thus the first row that's returned is, has the gender male because that's satisfying that first criteria, and then the next few rows are satisfying the second criteria. Okay, notice we use the double equals here. That means you're asking, is it equal to, compared to the single equal sign, which is assigning a parameter a value. You may well get an informative error if you try a single equal sign. So if I try that out and run it, then this usually means that you've used equals instead of double equals. And it even tells us what it thinks we should have done. Not all R errors are as polite as this particular one, but so it's a common mistake. So there's a nice thing to use. So a helper function for doing ORs in particular is the in operator. So you can see that demonstrated here. So say we wanted to pick the rows in the roll data where the year level was year 1 or year 2, then we could implement it like this with the OR operator. But we could also implement it using the in operator. So the in operator will return any rows where the level matches one of the criteria inside the concatenated vector here. So the C function here is concatenation. We used that earlier for colours, I think, didn't we? And so both of these get, of course, the same 22,524 rows. The advantage of the second one is it's easier to extend. So if we wanted year 5 as well, then we can easily just add it into that vector. Okay. Right, so let's have a go at some ourselves. So find all the rows corresponding to Queen Elizabeth College students in year 9. So this is going to be a filter. So we're going to want the school to be Queen Elizabeth College. And the level to be year 9. So we could just do it sort of one by one, couldn't we? So here, just to check that we get the terms right, because if of course I'd made a typo there, I'd get nothing. So that helps us. We can always copy and paste to make sure we get it right. So there's Queen Elizabeth College. And you can see we've got multiple year levels there, year level 10, 11, 12, and so on. So we want the level to be year 9. There we go. Okay. Find all rows where there are more than 100 year 9 Asian students. Okay. So we've got a filter on the students column, but we also are specifying Asian students in year 9. So we've got 3 criteria here. So we're going to be filtering our roll data such that we need year 9 Asian students. So the level is going to be year 9 and the ethnic group. Remember, tab will work. Oh, no, it doesn't. Tab will work later. We'll see tab starting to work again at helping out once we get the pipe. So we want Asian. So let's check that that's working. So we've got ethnic group Asian, and hopefully our year level is all year level 9. Yes, it is. So that's good. And then we want to return only the rows where the students are more than 100. So we need students greater than 100. Okay, find all rows where the school name starts with the letter G. Right, so we need a school name starting with the letter G. Okay, so we could use the hint by doing a string comparison there. And so sure enough, we have schools starting with the letter G, but of course we also have schools that are larger than. You can see how many rows we've got. We've got 84,000. That can't just be the school starting with G, because there was only 100,000 in total, and clearly 84% of them are unlikely to start with the letter G, right? So we need a restriction to ensure that it doesn't start with H, for example. So we'd have to put another one, restricting on H. And so that would give us the right number of schools. Okay, another way to do it is to use the starts, which is again a hint that we've been given. So if we look up starts, so if I'm just going to sort of type starts, put my cursor on it and press F1 to get the help for starts. And so you can see it takes a string and a pattern. So the string that we're going to be, so we're going to be looking for a particular pattern inside a string. So the string is going to be our school vector. And our pattern is going to be just the letter G. So there we go. That's another way to get the same thing. So technically this pattern could be a regular expression. So if you know about regular expressions, you can use much more complicated things in here in order to make more complicated matches than just starts with the letter G. Okay, so that's filtering. We can also arrange the rows. So instead of dropping rows, we can change the order. So we can see here that this first command is arranging the role data first by gender. So we've ordered females first and males second. So this has been ordered alphabetically. Then within gender, we're ordering by ethnic group. So Asian is first. And then within ethnic group and gender, we're then ordering by level. So level will be ordered year 1 first, and so on. And once we've gone through all the schools that satisfy that criteria, it'll jump up to year 2. I don't know if we'll see that. Oh yes, here we go. In fact, you can see that something odd happens. So after we've dealt with all of the entries in the database that have female Asian in year 1, you can see it jumps to female Asian in year 10. And the reason is that the level is encoded as a character string here, not as numeric, right? So it doesn't know that that 2 should come after 1 instead of 10. The reason is it's interpreting this as a character string. So the next string after year 1 is year 10, because of course 10 starts with a 1, so it matches the same thing. All we're doing is adding another character on the end. So ideally we'd convert this column to remove the year information, because that's not really required for knowing what the level is. Perhaps we could embed that in we could call it year level or something as the variable, and that would store that information. And then we could convert this just to a pure number, and then of course 2 would in fact sort after 1. The second line is arranging the role data by descending number of students. So if you want to arrange things descending, you just wrap the thing that you want to arrange descending by that. Okay, so you can see that the row that has the most students is this first row here, which corresponds to Tahu or Te Kura Punamu, which is the a correspondence college. So it kind of makes sense that that might be quite large. Okay, so let's do some examples. Arrange the roll by the number of students. Well, that's just the same as what we did before, but without the descending, so we can copy and paste that down. So you can see that the lowest number of students is 1. That'll be useful later. Find all rows where the ethnicity is specific, arranging them by decreasing number of students, right? So this is doing two things at once, right? So the first thing we're going to do is we're going to do a filter because we only want Pacific students. So ethnic group is equal to Pacific. Okay, and now we want to arrange this data set by decreasing number of students. So one way to do that is to store it. So we could say Pacific is equal to that. So notice when I run that, if you haven't run much R code before, I don't get any output. And that's because this is an assignment rather than a expression. So because I'm storing it, it has stored it but not printed it. But then we can arrange that. Of course, if we want to print it, we just type it out. So there it is there, and now we can arrange that data set by the decreasing number of students. So students descending. So you can see that Auckland Girls Grammar is the one that has the most Pacific students in one row. So it's not necessarily the most Pacific students. Instead, it's the most specific students of a particular gender and year level. So we haven't combined, we've got multiple rows here for each school. So it's not the largest school, it's instead the largest number of students in a single row. And of course, there's multiple rows per school. So we'll see how to combine that information later on to answer that type of question. Which school has the highest number of international fee-paying students at year 13? And we've got a hint, international fee-paying is an option for ethnic group. So we need international fee-paying students at year 13 first. So we're going to do a filter. So the ethnic group is going to be international fee-paying. Let's check that we get that. Yes, we do. And the level is going to be year 13. Let's check that we get that. And we do. So that's going to be year 13 internationals. We'll store that, and then we're going to arrange that descending by number of students. And we can see that we've got two rows again for UP, International College of New Zealand, which I think is at the University of the Pacific maybe. I'm not sure what UP stands for. But you can see that that has the largest number of students. Well, that has 57 male students and also has a number of female students, 33. So it's definitely the largest, right? There's only two possible rows per school here because the only way that they can differ are on the student column and the gender column. Right, so UP International College New Zealand has the most. So it'd be 57 plus 33, which I guess is 90. Right? We can use R to work that out if we don't want to do the mental arithmetic in our heads. Now, what we noticed that while we're doing this is that this data set, Year 13 International, is sitting up here in my environment, so is the Pacific, but they're only sort of temporary items in order to get to the final thing that I'm looking for, which is my output after arranging that thing. So I don't actually need these data sets. They're just sort of a thing that we encounter along the way in order to get our work done. So the pipe operator is a way around that. And the idea with the pipe operator is that it takes those, it basically removes the need for those temporary variables. So here's one way we might have done that. That last one, I did it in 2 steps, but here's an example of doing it in 3 steps, where first of all, we grab the international fee-paying students and save that. Then we filter that further to grab the Year 13 internationals, and then we arrange the Year 13 international students. So this way of doing it introduces 2 temporary data sets that are kind of thrown away later. All we're interested in is the audit output. We could instead do it all in one line by taking the output of those filters into the next filter, which then goes into the arrange, and that will run that same code without the temporary variables, give the same answer, but is extraordinarily unreadable. I mean, even if we added a bit of white space, like this, for example, perhaps like that, maybe we could even put that down there, and that down there, and that down there to give a bit of white space. Then what is this doing when you come back to read it? You actually have to read it inside out. So what it's doing is it's first filtering the role by ethnic group, then it's filtering that result by level, and then it's arranging by descending number of students. So this is complicated to read for a number of reasons. First of all, it's inside out, and second of all, it's hard to figure out what this argument is applying to. Even though we've added it, we've sort of added a bunch of white space to help clarify things, this level argument is applying to this function here. The descending students argument, which is way down here, is applying to the very first thing that we type. Okay, so it's not particularly readable, and one of the most important things in my view when you're writing code is that it needs to be readable to you, i.e. to the author, to future Jonathan, when future Jonathan comes back in a week or 6 weeks or 6 months to reread this code and figure out what it's trying to do. I hope that future Jonathan doesn't curse past Jonathan for their opaqueness. So we try and make things as clear as we can, either through documentation, so obviously we can write some comments as to what that code is doing if we wanted to, but it would be better if the code sort of helped us self-document. I mean, we could write here, this is filtering the role by ethnic group to pull out international fee-paying students, then by year for dropping down to just year 13 international fee-paying students, then arranging by descending number of students so that we can find the school with the most year 13 internationals, right? Ideally, I don't have to read that because the code should sort of say that for me. Both is probably more useful than one or the other, but ideally the code should speak for itself. So the way we can do it is with the pipe. So here's the other way to write that same set of code. So you can see we get the exact same answer, but there's no temporary data sets used, and it's very readable. It's in the order that we expect. We start with the role, we then do the filter by ethnic group, we then do the filter by level, and we then arrange by the number of students. So what's happening here is that whenever you get this operator here, which is called the pipe, this takes the argument on the left, which in this case is our data set, our role data frame, and inserts it in the function on the right as its first argument. So this is taking the role data set and inserting it as the first argument in the filter command. We then have another pipe out here, and so the thing on the left is the result of that first filter. So that would be the role data filtered down to just the international fee-paying students. That is inserted into the next filter as the first argument. So the second filter is filtering the first filter. And similarly, this pipe here is taking the outcome of the second filter and feeding it into the arrange. So this is a very natural way of ordering our code that is both readable, and in terms of like the plain English expression of that same code, and much clearer when we come back to it. Okay. We can interrupt it at any point. So for example, if I'm just sitting here and I want to know what the output to that is, I just put a hash in front of the pipe so that I can just run it, and then I get my filter result, and I can check that it is as I would expect. So I've only got international fee paying in year 13. Okay. So we could do a few of the things that we did above. So let's take one of the other ones. So here we had this combined one here. So here was the old code. Right, the new code would be, with the pipe would be, take the roll data. Oh, this is the same one. Hang on a sec. Let's get a different one. Let's get this one here instead. Right, take our roll data, filter it such that ethnic group. Now notice I pressed the tab button there, so I just typed ET and pressed tab, and it auto-completed the name of the column. So that's something that the IDE is providing, RStudio is providing to us, and it helps us not make typos, right? So there's that same code. Gives us the same answer, exactly the same answer, but is much more readable. Okay, so from now on, we're going to be using the pipe for everything. Just to note that there is another one. So there's the Migritra pipe, which is this one here. Does it show? Let's have a look. Oh, there's a wee footnote. So the other pipe looks like this. All right, which is this one here. And does the same thing, is less efficient. So the base pipe is new. It came out in R version 4.1 and was enhanced in R version 4.2. Before that, you had to use this one, which has been around for a long time. In RStudio, there's a shortcut. So Control-Shift-M is the shortcut for inserting a pipe. And if you go to Tools, Global Options, somewhere under Code, there's a tick box for using the native pipe operator. So if you have that ticked, then when you insert when you use the shortcut Control-Shift-M to put a pipe in, it'll use the native pipe or the base pipe rather than Migritra. If you have that one unchecked, then it will put the Migritra one in. It doesn't really matter which one you use. In that the number of cases for which they differ is very, very small, but nonetheless they do differ a little bit. And so you'll see that a couple of times throughout the course I will use this one in favor of this one, just because it does what we want. But generally I use a native pipe operator where I can, because we're going to be seeing this more and more in code that you find on the web. At the moment you may see more of percent greater than percent, but it's going to change quite quickly, I think. Okay, so selectors for choosing columns. So you can see here that we only return the columns that we specify. So take our roll data and just pull out the school, ethnic group, and students columns. So it's like filtering rows, but now we're filtering columns. Because there's different criteria for generally in the reasons why you might want to filter columns, it operates a bit differently. So for example, what does this next one do? Well, this example is going to return rows that aren't school because there's a minus in front of it. And it's going to rename the students column to number. Okay, because we've named the student argument. So select can also rename at the same time. And there's a bunch of select helpers in the tidy select package that are used for helping with column selection, and one of those is the everything operator. So here we're selecting the students column and the level column, and then everything else. So we're still returning all columns, we're just asking for the students and level columns to be returned first. That can be quite handy if you've got, like, you know, a few hundred columns and you don't want to scroll all the way through to find the one you want to look at. You can just pull it out first. Okay, so let's have a go at these. So rearrange the role data set so that students and level are first. So this is pretty much exactly what this does, isn't it? That's easy. Already done it. There we go. Try renaming the school column to name, keeping all of the other columns. So we're going to take our role data. We're going to pull out. So we want to pull out the school column, but we want to call it name. So name equals school. So let's check that that works. So we've got the school column and it's now called name, but then we want everything else. So we can add the everything operator there. Because this is a super common thing to be able to do, the rename operator does that for us. So the rename operator renames the things that you want, that you specify, but always returns all the rows and always returns all the rows in the same, all the columns in the same order. So for example, another one would be, I could rename the ethnic group then it does so. Okay, mutate is for adding new variables based on existing ones or other data. So let's have a look and see what this one's doing. So this one's computing a proportion. So you can see here I've got my new column proportion, which is computed as the students divided by the sum of the students. So what this is telling me is the proportion of all students that are in that particular row. So you can see that the ones will get the same proportion. I guess there must be around about 1.2 million students in this data set, around about 800,000 students in this data set, because 1 over 800,000 is about 1.2 times 10 to the minus 6. Okay, so what's this next command doing? Let's have a look. Well, we're taking the role data, we're creating a new variable level, which takes the old variable level, computes a substring with the 6 parameter. So this is taking, if we look at the help for substring, by pressing F1 on it, then you can see that the arguments are a text string, and then the next argument is first. So this is taking everything from the 6th character onwards, I guess up to the millionth character, I suppose, but there's probably not that many. So we're taking just the numeric part of the level string, and then we're converting it to numeric with the as.numeric argument, and then we're assigning it to the new variable level. So what we're doing here is we're overwriting the old variable level with a new one into a new dataset clean. So if we look at the clean dataset now, this is the same as the role dataset, same number of rows, but the level variable is now a double type, so it's a numeric with just the number. So this is going to sort correctly now. You recall before it didn't sort correctly. Just to note that this is inside out. Right, we've got as.numeric operating on substring, operating on level. I guess we could rearrange this using a pipe if we wanted to, or we could break it down into subsequent steps. So I could have done roll mutate level year equals substring level 6, right? In order to get that, just pull out the number, and then I could convert that to numeric, level number maybe. Aren't very good names, are they? I could convert that previous one to numeric, right? And so you can see I've got the converted to a number. Or I could potentially use the pipe. Let's see if that'll work. Let's think. Not sure if this will work or not. Let's have a look. So we're going to level is going to be take the level, pipe it into substring with first equals 6, and then pipe it into as.numeric. Yeah, so that works as well. Perhaps a little bit hard to read because of the multiple levels of piping. So I guess I might want to use a little bit of white space there in order to kind of, figure out at what stage things are happening, perhaps like that or something like that. I don't know. Okay, but that's another way to do it. Okay, using the clean dataset, create a new column combining ethnic group and gender with paste. So let's have a look at that. So clean, mutate, so ethgen maybe is going to be paste ethnic group with gender. Right, so here we're going to have a new column called ethgender that takes both of those variables and combines them together. Redo part 1, so the original 2 columns are removed. So we'll first do our mutate, and then we could just use select, couldn't we, to get rid of ethnic group and gender, using the minus operator to remove them. Sometimes my RStudio does strange things like this, where all of a sudden all the code disappears. I find that just closing it and reopening it does the trick. And fixing that up. Create a new variable age with the typical age of students in each year level. And we're given a hint here that year 1 students are typically 5 years old. So what we're going to do is we're going to take the level and we're going to add 4 to it. Right, so that students in year level 1 will end up with age 5, and students in year level 10 will end up with age 14, and so on. So this is typically the age when they start that year level. It's not always correct, of course, but it's an approximation. And finally, we're going to investigate using a helper function to do what we did before. So we're going to try the unite function from tidyr. So I'm going to take my clean data and I'm going to pipe it into unite. And then I'm just going to press F1 on unite so I can see how it works. So unite multiple columns into one by pasting strings together. Okay, so we can see that it takes the first argument is the data frame, so that'll be passed in with the pipe. Second argument is the name of the new column, so that's going to be our ethgen. And then we've got columns to unite in a ... argument, so we can put multiple columns in there. and then we've got sep as a separator. So let's have a look at the examples here. Okay, so I can see that I start off with a data frame with X and Y in it, and I just specify the data frames there. So let's just try specifying our columns and see what happens. Yeah, there we go. So that's worked. So notice that it's automatically removed the old ones. I guess the remove argument can control that. So if I go remove equals false, oops, then it keeps those other ones in there. Interestingly, it's also put it in the same place, which is kind of handy, instead of adding it on the end like our mutate did. And we can change the separator using the sep argument. Right, separator to use between the values, so we can put a space there if we wanted to, or a colon, you know, whatever you like. Okay, so that's the unite. So 2 more to do, summarize and group by. So the summarize function reduces our multi-row data set generally down to a single row by doing a summary computation on each of the rows. So for example, we've got 2 examples here. We've got the first line summarizes by creating a new column for rows, and it's set it equal to n. And n is a wee helper that returns the number of rows. Right. So all this is doing is just telling us how many rows there are. So this next command is then doing 2 computations. So the first computation, it's adding up the student column. You remember the student column represents the number of students of that in that school, of that gender, by that ethnic group, and of that year. So this is counting the total number of students across that whole data set. So this is the number of students in a school in New Zealand, which is 826,000. The second computation here is then computing an average. This is a bit of a silly average, really, because you can see it's the total divided by the number of rows. So this is the average number of students per row. So if you like, that's the average number of students at a school in an ethnic group in a year level of a particular gender, which is a bit of a silly thing to do. So let's try some other ones. So find the largest maximum number of students in any row. So we could use the max summary for that. Find the median number of students in any row. Again, we could just use the median function for that one. So the name I'm using here is, of course, arbitrary. Right, that's just what I want my new column containing the number to be. As per usual, even though these are only returning a single number, nonetheless, the data structure is still a tuple or a data frame, right? Because dplyr wants to keep that consistency. So it's not necessarily the best thing to return in every case, but it is at least consistent. If we wanted a number, we could use the pull. So if we pull med, then it will just give you the result. So that you could use it directly if you wanted to. Right, what are the lowest and highest year levels in the data? Well, I'm guessing they're year level 1 and year level 13. That's the usual range. So we'll just go min level and max level. So it goes up to year 15. I didn't know that, so there we go. It's obviously a couple of years after year 13 for some students. Find the number of Māori students in year 9. Right, so we're going to have to filter first, right, to just get the Māori students. So ethnic group is Māori. And then we want to total the number of students. So we want to do a summarize add up that students column. So 204,814 Māori students. So it's a little over 25%, or well, just under 25% by the looks. I think that this ethnic group classification is what's called prioritised ethnicity. The thing with ethnicity, of course, is that each person can be multiple ethnicities. So some people are going to identify as Māori and European, or Māori and Pacifica, or Māori and Samoan, or whatever it might be, right? So if you just add it up, so each person has potentially multiple ethnicities. So in this case, the ethnic groups have been prioritised, and each person has been assigned just one. So essentially what happens is the ethnic groups get put into an ordered list. I think it's Māori, Pacific, and then other, I think, which is a whole big group of Māori, Pacific, Asian, and then I think potentially other, and then European is the order. So if you have Māori descent, then you are put into the Māori box, even though you may also have Pacifica or whatever, right? That's the way that works. And the intention, it's often used in a health setting, so the intention is to recognise disparity and so that we can sort of deal with it. Okay, so those are the five basic verbs. The other one is group by, and it basically what the group by does is it allows you to do all of the operations that we've done so far by subgroups of the data at once. So when we run the group by command, then you'll see that it doesn't actually do any, like it gives you the same output. We've still got a table with the same number of rows, but now it has a wee tag in that it knows that this thing is now grouped by school. So any computation that we do, such as a summarize or a mutate or a filter or an arrange, will be done within each group first, rather than across the whole thing. So for example, in particular, this is useful for summarize. If we add up the number of students, that will then be done per school. So instead of getting a single line for your summarize, you'll get a single line per group. So in this case, per school, with the number of students. So let's see what happens. So now we can see the A1 student limited actually only has 25 students, and so on. Okay. So this is where sort of, the real power comes from, I guess. And it's usually the thing that suddenly makes people suddenly say, oh, this dplyr thing might actually be useful, because you can do most of the other things using other functionalities. Filtering, there's a subset command and so on. Ethnicity, so we're going to group by ethnic group, and then summarize total equals sum of students. Okay, so that's the number in each ethnic group. What about each gender? Here we go. I'm going to have to reload it, aren't I? Which school is the most female students in year 13? So again, it's a school. So, but we've also got a restriction on female students in year 13. So we can take our data and we can filter it. So we want female students in year 13. And then we want to group by school, because we want to know how many students there are by school. And then we want to know which one has the most, so we can arrange it descending. And so this is, again, Te Au o Te Kura Punamu, which is the correspondence college. Correspondence school. Okay, let's have another one. Produce a graph of the total number of students by year level. And we've got a hint there, get the data you want, then use ggplot with geom_col. Okay, so total number of students by year level. Okay, so group by level, summarize number of students. So that's the data we want. Now we need to put it into a plot, so we could pipe that into ggplot. And we're going to use a column chart. So a column chart has aesthetics for X and Y. So the X is usually a grouping variable. So in this case, it's going to be our level, and our Y is going to be our thing that we want the bars for a bar chart, the columns for. And so there you go. So you can see that there's actually very few students in year 14 and 15. Most students, of course, finish at year 13. There's this very strange peak at year 7. And from memory, the reason for this is that students are reclassified when they move from primary school, which is generally years 1 to 6, through to intermediate, which is years 7 and 8 often. So there's some reclassification that's happening, which means you get a few more than you would otherwise get. I believe that's the understanding. If you'd like to sort of, if this sort of piques your interest, if you like, if you go to the Education Counts website, educationcounts.gov.nz, there'll be an explanation on there about that process. So this type of thing is where ggplot and dplyr shine. So we want to alter this chart in order to include gender as well. So we need to do the summation of the number of students by level and gender. So we're just going to take that same code, and just by adding gender in 2 spots, we'll suddenly get a graph sort of partitioned down by gender as well. So we're going to group by level and gender, then do the summarize, so that'll have the total number of students by level and gender, and then we could perhaps fill our chart by gender. So now we've got the those bars broken down by gender, and we could put them beside each other if we wanted to, instead of stacked with position equals dodge. There you go. So you get a very interesting trend here where there are more males than females in all years up until year 11, and even year 12 there's a few more, but in year 13 it's very much the other way around. So we're seeing this trend where males tend to leave school earlier than females. So you get more males leaving school after year 11, 12 and year 12. So fewer males in year 12 compared to the difference that there is earlier, and fewer males than females in year 13 as well. Okay, again this is messing up. Right, and the last thing we're going to look at is some stuff on missing values. So you'll remember that when we looked at the penguins, there were 2 missing values when we first did our plots with ggplot. Where those particular 2 penguins were missing their flipper length. And so this is important because when we go to summarize and perhaps compute something like a mean, for example, of course you can't compute the mean if you have missing data, because you don't know what those missing data are. So R is going to helpfully return NA here, which means that it doesn't know what that number should be. It's short for not available. And we can fix this by adding na.rm equals true to the mean function, which tells it to remove the NAs first. Okay, so now we can compute the mean flipper length. And this same sort of setup will apply to many summarized type functions that have that requirement that they need to know the values. So you should be able to compute things like the median without knowing the values. Well, maybe you can't, because I guess technically you don't know where they are, right? Are they above or below? Let's see if we can compute the median. See what happens there. We'll call it median as well. We don't get confused. No, it can't compute the median either. Again, there'll be an na.remove equals true. Because of course it doesn't know where those missing values are, and that would of course potentially alter the median. You wouldn't think it would alter the median very much, I guess. It could potentially alter the mean quite a bit if they were, extreme. But that's how to fix this. So that's kind of often how missing values show up, is that they'll already be recorded as NA and R. So if we have a look at the penguins data by viewing it, right, you can see that some observations are missing. So this is a data set where the missing values are explicit. We've got rows in the data that just don't have numbers in them. But there are other situations in that missing values can be implicit, where essentially the whole row is missing. So for example, if we looked in the school data, there's no NA entries at all. Every single cell in that data set has an entry. However, there are still missing data in that data set. So as an example, if we wanted to compute the average number of each gender across schools, we might try this technique here, where we group by gender in school and summarize the number of students. Right, so let's execute that bit of the code. Right, so for each school and each gender, we get the number of students. And then we're going to group by gender, and in order to take out the school effect, and sum the number of students. And compute the average number of students. So there we go there. So we've got the answer 163.18 females and 171.8 males. But that answer would be wrong. And the reason that answer is wrong is that there are no entries in our database, in our data set, that have the number of students equal to 0. Right, we can check this with a filter. So if we try and find the number where the number of students is 0, there's no rows returned. Yet we know, of course, that some schools will have no students of a particular ethnicity, gender, and level combination. So it's a simple case would be single sex schools, right? Single gender schools, where in a Palmerston North Girls High School, there will typically be no boys, and at Palmerston North Boys High School, there will typically be no girls, right? So those combinations don't appear in our data. And we can see this just by totaling up the number of schools and gender and then taking a look at a certain set of schools. So in this case, let's have a look. We're grouping by gender and school. We're computing the number of students in each school by gender, and then we're filtering down to schools that contain the word grammar. That's what the str detector's doing. Detect the word grammar in the school column. So you can see we've got Auckland Girls Grammar, which clearly doesn't contain any male students, right? We've only got the female students. So there should be a row here for Auckland Girls Grammar School and gender male containing 0 students. That would be important if we were computing a mean, right? We're missing all the zeros, and so the zeros aren't going to contribute to the numerator of the mean, right? Because you add up all the values. Adding zeros isn't going to make any difference. But they will contribute to the denominator, right? The number of rows, because we're missing the 0 rows. So at the moment, our means that we've computed, our averages, are going to be too high, okay? Because we're missing those zeros. So a fix for this is the complete function. So this is it here, right? And you just tell it to complete on gender and school, which means that it will ensure that all possibilities of gender and school are present in the database, right? So let's run that and have a look. So now you'll see that we have a row for male at Auckland Girls Grammar, and similarly a row for female at Auckland Grammar added to the data. So it's completed it by taking all possible combinations. So if you like, this is a cross join if you've done some database stuff before. So it's all possibilities of the gender variable, which is just female and male, and all possibilities of the school variable, of which there were 7. And thus ensured there were 14 rows, right? 7 times 2. Of course, the computer doesn't know what the value should be, so it's giving us NA. So the complete function takes those implicit missing values and replaces them with explicit missing values. Of course, in this case, we know, as the human driving the computer, what those numbers should be. They should be 0, right? So there's a couple of ways that we can do this. So let's take that role. Right, so it suggests using the fill parameter of complete, or alternatively using the replace NA function. So let's have a look for the help of complete. So turn implicit missing values into explicit missing values. So it's a wrapper around a bunch of things, expand, full join, and replace NA. But it's one of these things in dplyr that's a convenient thing that is done frequently, and therefore there's a single line for it. So you can see that it's got a fill argument which takes a list. So fill is a named list that for each variable supplies a single value to use instead of NA for the missing combinations. So let's have a look down here at the example. So here we've got an example, a table, and the value 1 column has an NA. Okay, and we're completing on the group item ID and item name. And down here we've got an example of using fill. So when you use fill, you specify a list, and in that list you put the name of the column and what it should be set to. So in this case we're replacing value 1s by 0 and value 2s by 99. So in this case we want to add in here fill equals list, and the variable that we want to replace is going to be students, right, because that's the one that's NA, it's the students column, and we're going to set it equal to 0. So there we go. The other way to do this would be use replace NA instead. Alright, so we run the complete, and then we could do replace NA. So let's have a look at the arguments for this. So it takes a replace argument as the second thing. If data is a data frame, replace takes a named list of values with 1 value for each column that has missing values to be replaced. Okay, so the same type of thing. So replace equals a list, and in this case we want students equals 0 again. So that's how to replace NA works, same thing. Okay. Oh, sorry, that's supposed to be down below. Oh, I've done all this in the wrong spot. Let me fix this up so it's not confusing later. So we want that there. We want this one back up above. There. Okay. Okay, with the NA values replaced, recompute the mean number of male and female students across all schools, right? So we can do this using the same code. So we're going to take our school. Right, so that gives us our completed gender by school table. Okay, let's arrange it by school just so that we can see that it's done what we think it's done. So you can see I do have two values for each one, and presumably at some point there'll be one that has some NAs in there. Might take a wee while to find one, because most schools, oh here we go, got one. Okay, there we go there. And so now we can do our computation of the average number of male and female students across the school. So we're going to group by just gender, and then we're going to compute the mean number of students. So you can see that they're lower than what we had before. So we've got 159.8 and 166.5. Before, when we did that computation, we had 163 and 171. So these were too high because they didn't have the zeros. The zeros don't contribute to the numerator, but they do get added to the denominator. So adding the zeros in makes the denominator bigger, which makes the number smaller. Okay, so the correct numbers are here. So it wasn't too far wrong, I guess. But of course, we never know until we do the computation. So it's just something to be aware of whenever you have data, is to think, what about, what are the rows that I may not even have here? So not only just looking at your missing values that you do have present, but what about the ones that didn't even make it into the data set?